Okay, it is 11:30 a.m. here on Pacific time and 2:30 p.m. out on the East Coast. So we're going to go ahead and get started. Welcome everyone. Welcome all participants to one of our Ausenco Connect webinar series. This time we're going to be talking about mine to market, discussing with Joel Sheriff, who's with me virtually here today, about holistic approaches to transportation for mining projects. Firstly, I just want to say, Joel and I can see the participant list, and it's just great to see so many familiar names on the list. Really unfortunate that we aren't able to do this in person. Haven't seen many of you in a long time. Hope you're all doing well and staying safe during this difficult period. It's great to be connected with you even through this forum, and hope to be able to see many of you again in person at some point in the not too distant future. But all the best. Looking forward to spending the next 30 to 45 minutes with you. Before we do launch into it, a couple of housekeeping items quickly. We would appreciate receiving questions. So if you do have any questions, there's a little Q&A panel on the bottom right of your screen. Please go ahead and type your question in there and just hit send. And we will be tabulating those and trying to answer them over the course of the discussion or at the end. Then I just wanted to inform, just for sake of transparency, we are recording this webinar and that a replay will be sent to all participants afterwards via email. So without further ado then, firstly, I do want to introduce Joel, who is joining me on this webinar today. Joel is, for those of you who don't know Joel is a globally recognized materials handling expert. I'm a registered professional engineer with over 30 years of experience in the development and operation of bulk terminal projects around the world. Joel, together with myself, we're both based in Vancouver. Joel is Ausenco's Vice President, Global Practice Lead for Terminals and Transportation, and was previously employed as a manager at a multi-cargo bulk export terminal for more than 15 years, where he supervised terminal expansions and major maintenance projects, as well as managing the operations environmental systems. As part of his consulting practice, Joel focuses on services to optimize existing facilities, applying lots of his personal experience in managing issues around environmental protection, safety, and operational efficiency in multimodal transportation and ship loading operations. Joel's real wheelhouse and areas of expertise include bulk terminal design and construction, commodity transportation system studies, asset optimization studies, operational audit studies, and due diligence consulting. Very honored to be with you here today, Joel. Myself, I am Chris King Sidney. I am the president of Ausenco's consulting practice. This is a global practice that spans across all of our core markets in North and South America and in APAC. Multiple different practices, including environmental consulting and transportation logistics consulting, as well as various others, all fall underneath my remit. And I will be moderating and engaging in Joel on this very exciting topic today. So with that, I'm actually going to hand it over quickly to Joel to do a brief values moment, which is something that is very important for us here at Ausenco and something that we begin every meeting with. So Joel, over to you for a value share.
Great, thanks, Chris. That was probably one of the most generous introductions I've had in all my conference presentations. Maybe I kind of like this virtual world. I'm going to start out with an apology to those on the call that this is the first time I've had to actually do a conference presentation as a webinar, and so it's a new world for me. We've had to move forward in technology, and dragging me along with it. So it's looking forward to the opportunity to present with you today. As Chris mentioned, we'd like to start every presentation or meeting with a value share. On the screen, we see our 6 Ausenco core values, which essentially drive our behaviors and how we do business. And specifically today, I just want to talk about a little quick safety share around protecting our next generation workforce. It's something that I take kind of personally. We all have responsibilities to look after our workforce and those in the community, even when we work around us. Leading by example, wearing PPE, having courageous conversations with people when they are doing something that you might see as unsafe. But the thing that I've had some great personal experience around is passing down my experience in safety through to my daughter. And she's grown up seeing me wearing what other people might consider excessive amounts of PPE doing yard work, but it's just the way I live and breathe. We have conversations around it. And now that she's in her third year of mechanical engineering school, we're actually having really engaging conversations around safety and her observations of things in the world. It makes me feel great that I've empowered her to have that foresight and the willingness to have conversations with her. And she's even taken it further to have conversations with her own friends. And she has a friend that is actually just entered the workforce as an apprentice carpenter. And so she's had conversations with her around safety in the workplace, and specifically around the different standards that are applied between what we're used to in our industrial workforce and what her friend is encountering in residential construction. So it's really neat to see how that's moved forward for her. So the message here is have those conversations. You can never talk about safety too much.
Here. And it's important to be so courageous with those. So thank you for sharing that. And thank you for setting a great example for your daughter and for many other up and coming professionals in this industry. Super, super important.
Yeah.
Okay. So on to sort of what we're going to be talking about here today. So really the key question that we're really going to be discussing with Joel is around why is transportation an important consideration to mining projects, right? To be frank, often transportation is an often minimized or overlooked component of a feasibility study. You know, we've seen many times in the past where a majority of the focus of the analysis and of the work is really around the ore body and the processing. And not to say that those aren't incredibly important, but just wanting to highlight that, you know, transportation solutions and transportation and logistics can often present challenges, very significant challenges, you know, whether we're talking about product outflows, as well as supply chain for consumables, equipment, fuel, et cetera, et cetera. These can represent a pretty significant portion of overall project costs and can impact the viability of projects. You know, and additional costs and challenges related to communities and the environment also complicate feasibility studies, the feasibility of transportation, supply chains, and feasibility of projects. So really, this is a very, very important topic, and it's something that we focus on significantly, extensively in the transportation logistics group at Alcenco. And really, in our experience, a holistic evaluation of the entire project, of the process plant, the associated infrastructure, is required to optimize really the overall mining project. So what we're going to do today, if we can move on to the next slide, is that we're really going to unpack this a bit. We're going to look at what we think are 5 overarching key challenges or issues that we often see with these projects, and the question that you, the audience, that developers, that companies should be asking as you look to address and explore these different challenges. So I'm just going to introduce them briefly here, one by one, and then Joel is going to deep dive for us into each one of them. So the first one really is around topography and ecosystems, right? Those can often be significant challenges. So actually, we could go back to the previous page, please. No worries. And the question here really is, does the transport route require crossing, or is it over or around challenging geography or ecosystems like lakes, rivers, or mountains, right? The next one that we're going to be exploring has to do with resource scarcity in remote locations. It's probably not a shock, not a surprise to all of you that, with remote site locations, getting access to power and water is a challenge. So is the mine site extremely remote, and or does it have limited access to power and water? The third question. And this really has to do around ensuring that transportation systems are fit for purpose for the actual mine project itself. So one of the key questions here to look at is, what are the annual production rates into and out of the process plant? Fourth question we're going to be looking at has to do with existing infrastructure. What existing infrastructure can be used or expanded for the project, and at what cost? And then finally, we'll wrap things up with taking a much more of a holistic view of the entire project development process to see whether or not there can be trade-offs in terms of potentially investing in more in different parts of the value chain, i.e. can any part of the mineral beneficiation process be deferred to a downstream location? So let's go ahead and unpack these one by one. Joel, if we could move on to the first one. So as I mentioned, first one here, Joel, it'd be great to get your thoughts on, when we have projects that have to cross difficult topography or sensitive ecosystems, what are some of the challenges that you have seen in this space? And it would be great to hear from you, what some of the solutions are that we've been able to implement or that you've actually seen us have success with different projects around the world.
Yeah, thanks, Chris. I think there's very few projects that actually don't encounter some sort of geographical restriction, whether it's physical geography in rivers, water, mountains, or community impacts that trying to get around that. There's a lot of things that will require some innovative thinking around the type of transportation mode used to get around or over or through some of these restrictions. The picture below the question highlights a lot of the different, some of the different options that we've looked at in the past: ice roads, overland aerial conveyors, slurry pipelines, barging. There's a whole host of things. So one example that came to mind when we were putting this together is a project that it's maybe further removed from North America than most people are used to, but we do a lot of international work, and this one project in Sierra Leone posed some really interesting challenges around an iron ore process facility that was being developed inland from the coast. Really dense jungle, hard access to get to the place, but there was a river that was first initially thought to be in the way. It meandered its way down to the coast, but it actually, once we started examining things, it actually ended up being one of the solutions for us, which ended up using a barge transshipment arrangement to be able to load barges and move those to the coast and transship them into Cape-sized vessels. That took a lot of work in terms of understanding the water flows in that particular river, and avoiding any dredging and making sure that we could maximize our throughputs through there. So it involved both our coastal engineers looking at the hydraulics of the river and understanding what draft we would have in different seasonality, combined it with our simulation modeling tools to be able to look at the throughputs that we could do in that. Ultimately, it was a great solution where it was very minimal infrastructure and impact to the surrounding environment. Basically, we were able to load barges very close to the process plant, and was able then with those barges to develop a very robust and reliable transport system to be able to get product to market. And a number, and I'm not, the second bullet, where a lot of trucking routes end up running past communities. It's not something unique to any particular project. I've run across this in a lot of places, whether it's in Asia or South America or other locations where communities just don't like seeing that large volumes of trucks. And when you're getting into larger projects where you could see 100 trucks a day going past an urban community, some of these underdeveloped areas where it's a dirt road, the dust is being kicked up, potential for fatalities or accidents, interactions between the public and trucks. That's a recipe for disaster long term. And one of the solutions we've applied is slurry pipelines are certainly something that Ausenco has a real specialty around. It eliminates that trucking component through those communities. You can do it separately with overland conveying. A number of other combinations of those that we've applied in different scenarios. And like any of these, it takes that holistic approach and looking at not just one one option. You need to look at that full bag of tricks that you have available to you to be able to get around those geographical challenges. But
and with that, Joe, presumably there's obviously we need to look at trade-offs, right? Because you're going to be choosing one form of transportation over another. And what in your experience, what are sort of some of the key criteria, if you will, that need to be assessed in considering and developing these different trade-off studies from different modes of transport?
Well, I'm saying you need to look at the full life cycle of the project as well, because ultimately it comes down to the project economics, and the net present value is going to drive whether something's going to work or not and allow that project to move forward. So if you're looking at a really short-term project where you're only going to be operating for a couple of years, well, maybe you scale it down and trucks are what's going to work for you. When you start looking at doing a trade-off against the capital investment in a overland conveying system or rail or a pipeline system, that needs to be weighed against the operating costs and then the long-term cost for that project. That's something we do for every project we get involved in, is looking at those overall economics. You can look at leasing costs to try to reduce some of your operating costs, and there are a lot of different things that can be done to make some of the assets transferable so that you're not realizing some of those costs all the way through.
Good. I have a question. Another question just came through from a participant. When considering moving material around at a mine site, what solutions would you consider? Have you looked at the rail air option? Do you believe truck hauling still makes sense in 2020?
Well, yeah, certainly I'm familiar with rail air, and we've actually looked at it recently for another project. Actually, recently in a trade-off, and in the right scenario for a shorter distance, the rail air actually can be competitive against trucking. We've seen that. There haven't been that many of them installed to get a lot of benchmarking around long-term operating costs and the sustaining capital that needs to go into those. But absolutely, there are options, but trucking will still always be something that we have to manage. And there are ways of dealing with the trucking that could sort of reduce some of those impacts. Going to higher capacity trucks, using a containerized cargo versus open conventional bulk trucking. Those sort of things that can reduce the community and environmental impacts of trucking.
Fascinating. Good. Thanks, Joel. Let's move on to the next question then, just to keep, next topic to keep things moving forward. So here we're going to be tackling the challenge of remote sites and the limited access to power and water in those remote sites. Obviously, as sites become more and more remote across the world, there's going to be greater likelihood of potentially zero grid access or without reliable sources of water. We see this as a real challenge for many of the projects, many of our projects in South America. Really, the question here for you, Joel, for you to maybe unpack for us a bit, what are some of the best practices that companies need to consider when evaluating sustainable and reliable sources of water and power in some of these remote locations?
Yeah, so resources are going to be, and they continue to get more scarce and challenging. Being here in Vancouver, where it's always wet, and you have generally abundant sources of water, you perhaps lose that perspective of the difference between here and, say, the Atacama Desert in South America, where water is so scarce that you really have to understand how you're going to, one, conserve that and be able to generate new sources of that to be able to sustain an operation. Like, similarly here, power is more abundant, but there are a lot of locations where you have to look at potential renewable sources of power, but in some remote locations, you have to figure out how you're going to generate power and do it efficiently, and how you're going to fuel that power generation. So, common challenges I mentioned, copper mine development in the Andes is definitely probably one of the biggest challenges we've been facing in recent project development, and some of the things we've done to make that, and a prime example is a project that is actually in construction right now, where we have a copper concentrate plant located at 3,000 meters plus elevation, where it's a very steep grade down to the port, where we're having to develop an entirely new port facility, and we're using slurry pipeline to move concentrate from the mine to the terminal, and following a selected route that allows that to happen. The slurry is then filtered at the port, and that filtrate needs to be then, it's essentially dirty water at that point, where you've removed as much of the valuable product out of it, that needs to be returned back to the mine site to be used up at that point. So that same slurry pipeline corridor has a secondary pipeline for returning fresh water back up to the mine. But at the same time, there's going to be a negative water balance in doing that. So in that same facility, we've established a desalination plant that would create makeup water for feeding back into the mine site where the original sources of water are quite scarce to begin with. Now, obviously, desalination plants absorb more power, and it's an additional cost for our clients to be able to function. But our holistic approach and being able to apply that and implement that desal plant as part of the port facility allows us to have the additional infrastructure, that the intake piping and the diffusion pipe for returning brine to the sea, tied into the marine infrastructure that we were already building for that new port facility, so that it, one, reduces the net cost, and also reduces some of the impacts on the marine environment that we're doing that work in.
And that sort of leads me to a follow-up question on that, Joel, which is obviously, you know, ESG is a bit of a buzzword these days. Investor attention on that, and you know, we are definitely seeing that for many projects that are either being contemplated or even existing ones, the investor focus on trying to minimize carbon footprint, minimize you know, social or other issues is critical. So how do you see with this, you know, with some of the solutions that you've identified, is there an opportunity here to minimize the impact or to provide social benefit to local communities in the form of access to power or water? Could you speak a bit to that?
Absolutely, and you know, it's funny. It's nothing that should be considered something new. It's gained renewed focus, and certainly people are talking about it a lot more. One of my early projects when I got into consulting was a project in Madagascar where at that time worked with a client around having to build infrastructure for a new limestone aggregate facility that needed a water supply. And as part of that, we actually discussed the fact that this community in Africa that was adjacent to the particular mine site had one well that they walked to get to their water supply. So building into that, we agreed that the most appropriate thing for responsibility of that client was to nominally water production plant that we were putting in, reverse osmosis filtration. It wasn't anything earth-shattering, and to generate enough water that actually would support this community of a few thousand people that would improve their way of life. So there's a lot of things that can go along with being able to provide water to the local communities, providing power in that same sense as well.
Very good. A question here came through. I assume the desalination plant, I guess in reference to the example that you gave earlier, Joel, was using reverse osmosis technology. What were you doing with the membrane reject, the slurry, highly charged with salts? Yes.
So, and that's I think I made mention that the outfall from the brine is what the reference term for that is, and then also then piped back out. But you have to do, and it involved a lot of work from our coastal team to understand the dispersion effects for being able to put that brine back into the sea. But if you take it up far enough and using the infrastructure we put in place, you get it far enough away into deep enough water that you do the ecology effects, and that the brine dispersion happens and putting it back into its where it once came from.
Good. I'm glad you're here to answer those types of questions, Joel, because I wouldn't be able to scratch the surface on that one. So good to have you here with me. Okay, let's move on to the next topic then. All right, so here, this is I mean, the question here is, what are annual production rates into and out of the process plant? And to provide a little bit of context to our audience before Joel gets into the details on that, you know, ultimately the size, type, and scale of transportation solutions on these projects are ultimately determined by production volumes, you know, by the peak, the steady state, and also the ability or the need for future expansion. And boiling down to, there's not a one size that fits all for projects with transportation solutions. So critical question here is to look at just what the expected annual production rates are. So Joel, maybe you can take it from there, provide a bit more context and some of the best practices you've seen.
Sure. As you say, one size fits all is not the approach that anybody should be taking. You're not going to build the same kind of infrastructure to support transportation for 100,000 tons a year of copper concentrate that you're going to do for a 50 million ton a year iron ore terminal. You're going to have a wide range of facilities, and there's going to be fine lines in between. Expansion is something that needs to be considered along the way, and worked on a number of projects where you don't want to build in that. I've had clients use the term regret capital, where they've pre-installed too much in advance, but there's opportunities to minimize that regret capital and be able to do it in a staged manner where you can facilitate some of those expansions later on. And there are facilities where they've been constructed based on a designated throughput where there are opportunities to expand, and you need to think innovatively around that. So in understanding the longer term capacities, what we've done is a lot of clients will say, I'm going to have this plan for expansion down the road. I'm going to have twice the throughput, so my ship loading rate must be twice. And there's a misconception around that you don't necessarily have to build twice the infrastructure. And often a facility, if you build it appropriately at a lower throughput rate, you might actually be using it less than if in the expansion case. So say you build something that's slightly higher capacity rate to basically take on norms and standardized equipment. You're never going to, if you have a really low production rate, you're not going to put in a very small conveyor that's not going to have any expansion capacity. So you build in a moderate amount that might actually cause maybe a 20% increase in capital, but gives you that future expansion plan, and run it at a 30% or 40% utilization, so that your operating costs aren't as high. You have some pre-invested capital, but then when you go to have your expansion, provided that you've got a fairly good chance of that happening, then you run that into the full occupancy of that facility, and you increase the utilization rate so that you don't actually have to change anything other than perhaps the storage volumes to manage to the ultimate capacity of that facility.
Just another question that came through here, Joel, and it's around peak production rates. So the question is how to best account for variability in production rates, i.e. how to cost effectively design to account for peak production years.
Yeah, so, and that comes into a bit of the utilization factor, and a lot of times that we can analyze that in a more definitive method using our simulation modeling teams to look at what the impacts of peaks and valleys will be. You will typically have an operation that if your nominal rate is X and you're adding another 20% onto that for peaks, if that peak is rather short, you can accept that. You design the facilities for a peak for a nominal rate that would include a certain amount of maintenance and downtime, and during those peak periods, you forego some of that planned maintenance and plan your maintenance around those periods, such that you have a higher utilization rate on that facility during that short peak period, so that you're not over installing. The converse is, if that peak period lasts for say a 3 month, if it's extremely seasonal, where you've got low rates in the summer and high rates in the winter, you really have to accept that you're going to need to have that system designed to that ultimate peak rate. But short bumps in peak capacities, they can be leveled out just through operational preparedness and utilization of the equipment.
Good, thanks. Okay, let's move on to the next question then, the fourth one. One
thing I didn't actually, I'm just sticking on the slide, the last bullet here is an example of where a terminal that was pre-constructed to a certain capacity had a demand for additional throughput, and there was a restricted space that the facility had no more footprint to be able to grow. We looked at it and did some modeling and came up with the scenario where the conveyors could actually be run faster to increase the instantaneous flow rate of those conveyors, and ultimately we proved it in simulation, executed it, and the facility was able to gain another 80% of capacity with no increase in footprint. And I think we implemented that project probably about 8 years ago, and that facility had only some short 2-week outages while we did upgrades to some of the individual conveyors. So there are options around having some innovative thoughts on increasing capacities in facilities.
Okay, good. So on to the board. All right, so here, question around existing infrastructure. And really this is that, we've seen in recent years the need to develop new infrastructure to support projects, whether those be roads, again, rail, ports, or what have you. This can often become pretty cost prohibitive and challenging to execute at the same time, right? So this begs the question, do alternatives exist from having to build your own infrastructure? And if so, what do those alternatives look like?
Absolutely. I actually gave a presentation at a conference a couple of years ago specifically on this one topic about diversification of existing infrastructure, and that there's, as our economy grows and different regions change, where a particular facility might have been busy moving general cargo or containers, that facility may actually have less demand and have opportunities for diversification, whether it's a general cargo or container facility or even a bulk facility. There's opportunities for moving different cargoes through that. There are obviously some geographies, and depending on where your mine site's located, you may have to develop an entirely new facility, but there are a lot of opportunities to make use of existing infrastructure and diversify. And so when you look at a remote location, that particularly small producers, the worst thing you could think of is having to build an entirely new port facility or transportation network for 100,000, 500,000 tons of cargo. The cost per ton is going to be phenomenal, and it's going to make that project not functional for you. So looking at existing facilities, so now we've made use of existing cargo facilities, and the picture here is actually showing an example of a containerized bulk, where the general cargo container facility is actually loading bulk cargo into bulk carriers with the open top containerized bulk container, where the container is actually rotated upside down and the cargo dumped into the hold. That's a system that we've implemented in a couple of locations. It was originally developed in Australia, but it's growing in popularity. There's a number of facilities in South America that are implementing it, and I've got probably half a dozen studies here in North America where that is going to be the prime mode of transport for moving concentrates to market. Making use of existing facilities that would otherwise be sitting lesser idle. So another arrangement that we've come across is for smaller producers to be able to connect them with others and allow them to combine their net output into a single facility, so that that's diluting some of the costs. So a multi-user bulk facility is a great way of diluting some of those initial capital costs. Obviously, the operating costs will continue to be what they are, but it combines also with another concept of being able to blend your cargoes with others to match market demands. So having a common user blending facility is another way that we've been able to help our clients get their projects across.
Would that same sort of common user facility apply also to pipelines or rail, Joel?
Yeah, and my former employer is a great example of where a common user facility for different cargoes still functions, and where we've got coal and potash operating through a single facility. That there are two very diverse cargoes, but it's utilizing a single operating team, reducing some of the operating costs. Obviously, there's still going to be capital associated with that, and that's using unit trains to be able to move cargo more efficiently from inland to the coast. And yeah, there's a lot of opportunities. Whether it's in pipelines, you can actually use a pipeline to batch cargo through, so that we've had a number of discussions in South America around a common user pipeline arrangement where Ausenco would actually be able to build and operate a facility that could move individual customers' cargoes through it.
Yeah, very interesting. I imagine there's definitely challenges with that, right? If we're thinking about common use pipelines. But anyway, that's maybe a subject for another conversation. But it's an interesting one to think about, because surely with lots of smaller users, there could, to pool that demand, whether it's demand for water or demand for the slurry, there could be significant uptake. But anyway, like I said, the topic perhaps.
And again, that takes away from some of the trucking, the smaller outputs that would, their only resort is going to trucks. If you can come up with a way that you can manage their cargo for them in a different way, it's taking that outside the box view of how you're going to manage it for them.
Okay, well, let's move on to the last one here, just cognizant of time. So finally, and this one really is a bit more of a holistic question. Taking a critical holistic assessment to the entire project development, from process to plant to the export site, and ultimately to the final takeoff customer, is critical. And I'll let you speak to that. But really, the question here is, and with that, can there be any optimization? Can any part of the mineral beneficiation process be deferred to any downstream location? Can we invest more in one location to help save elsewhere? So what are some examples there, Joel?
Yeah, and absolutely, that's actually, I think, a prime example of what Ausenco does really well in terms of, I represent our transportation and downstream capabilities, but we engage holistically, looking at the whole process and how we can bring value to the project with our clients. And that often means that maybe doing some scenarios where you are deferring costs, some capital costs to take on additional operating costs, or taking penalties in the product as you're moving it through. So this first example is a mine development where the mine life was so short, but there's already existing process facilities nearby. And in that case, we actually looked at running basically doing some primary crushing, taking the run-of-mine ore and moving it from that mine site by rail to an existing process facility a couple 100 kilometers down the road. It added that extra operating costs of having to move that ore by rail, and it's certainly a lot more ore when you consider that product movement versus concentrate, and that there may be some trade-offs in different projects where you maybe do some further beneficiation at the mine site to change it to a concentrate versus moving it as ore. But it reduces the amount of infrastructure that needs to be constructed and process plant that needs to be constructed at the mine site, especially if it's only a short mine life, where your depreciation on that asset is going to be huge. So it also could be timed with a facility that has had a change in production levels where that existing process facility is underutilized too. So there's options to look at that. And I think I made mention of moving concentrate. Another project was looking at a gold mine where they had additional ore bodies that were further away from the primary process plant. But again, the cost of trucking or moving run-of-mine ore was much too onerous to be able to include and make the project viable, where they could actually put in a small Benny plant that would actually create some concentration on the gold ore to reduce your transport costs, and that trade-off ends up working out to be a viable option for the project.
And I would sure not only a viable option, but presumably there could also be some environmental, social benefits to that type of solution, right?
Well, absolutely. There are a few real nasty things associated with gold projects that some environmental regions don't like, whether it be arsenic or cyanide. And if a process is requiring cyanide and that you can't use that in that area, then the only option you have is moving concentrate. So that certainly, if you can make that financially viable, it also then has the going back into the root of sustainability. It's you do something different that not only improves the resource and the impact on the environment, but actually still saves you money too.
Very good. Well, thank you for that, Joel. I do an obligatory COVID-19 question has come through. We wouldn't be at a webinar in 2020 if we didn't have a COVID-19 question. So the question here is just, Joel, in your view, has COVID-19 in any way impacted the challenges that mining companies face with their transportation logistics supply chains, and if so, how?
I think initially it did, because obviously there was uncertainty in workforce and being able to have people in place to do it. Obviously, the impacts are going to be different on the different transport modes. Truckers, well, they have they're pretty much isolated, so I think that's a safe option. Similarly with rail, there's enough capacity to keep people safe in that space. It really came down to the terminals and being able to make sure you had a reliable workforce and capability to avoid having a terminal shut down. So initially there were some challenges around that, and here in Vancouver, where we have a lot of facilities, I've not heard of any of them getting shut down at this point. They've had some cases where people have had to isolate, and there are transient workforces that at play with longshoremen as well. So that there's challenges associated with that. But I think the transportation industry in a whole has been quite resilient in being able to manage it.
Fortunately so. I mean, that's good. Okay, well, look, that kind of wraps up our 5 critical questions. Any parting thoughts that you wanted to give, Joel, today?
No, and maybe I'll just use that as a segue into this final slide, where it's a bit of a pitch statement from Ausenco to the audience, but it really doesn't matter what kind of transportation mode you use. Ausenco covers the gamut from rail, trucking, conveyor, pipelines, and the such, but you need to do that analysis. You need to do the trade-offs and looking at how you can improve your project economics. And it's not rocket science. It just takes a little innovation and some experience to do it.
All right, well, thank you, Joel. Thank you to everyone who took time out of your day to join us. Hopefully this was insightful. We will be sending around, as mentioned, we will be sending around a recording of this webinar session to all participants. And encourage you to reach out to either Joel or myself if you have any further questions. We look forward to hearing from you. And thanks, everyone. Stay safe. All the best. Hope to be connecting with you at some point in person in the near future. Thanks, and have a good week. All the best.
Thank you, everybody.